All right, so I'm going to show you the shortcut to graphing quadratics. Well, pay attention. If you taking notes helps you remember this, then go for it. Did anybody happen to notice anything when A was 1? Look at all your graphs when A is equal to 1. Look at all the ones that you graphed. So here's one where A is equal to 1.
They're all like symmetrical?
Yes, they always will be, no matter what. Every parabola will be symmetrical. Here's one when A was, yeah, it's a -1, so that just means it's upside down. Well, there's a pattern. There's a pattern that I want you to notice. So look at these. So I have my vertex.
Oh, wait.
And then I'm doing something. That's just by chance. You're right. That's just by chance, though. They may not always have that. Like number 3, I think our vertex was at 2, 4.
Is it the same rule that you told us about? Remember that lesson where you had a graph that was like that parabolas?
Yeah.
And there was like you said there was always like a rule to it?
There is always a rule to
It's
it.
the same rule. I forgot what it was, but like,
I don't remember ever teaching you that.
not this, but like, it was a different way of graphing, but they were still used. And they like crossed something. They always like cross a line or something. I don't know, they always supposed to cross lines.
Well, here's the, yeah.
They're all like this.
Well, that's kind of part of it. If you look at any of your graphs when A is equal to 1, is everybody looking? Remember, this is the very important. So here's just a random graph where A is equal to 1, or -1, doesn't matter, because -1 is just going to make it upside down. From your vertex, to get the next point, you literally just go up 1 over 1. Look at all of the ones from your vertex to get your second point.
I knew it.
In this case, it's upside down, so I went down 1 over 1, but it's just 1 squared away, right? Then the next point, so the second point out, is always up 3 over 1.
I know this.
As long as A is equal to 1, it always follows this pattern. So from the vertex, you just go up 1 over 1, up 3 over 1. If we had a bigger graph and I was doing another point, guess what the next one would be?
3 over
6.
2 over 2. 6.
I went up 1, I went up 3, so then I go up 5. If you did another, it'd be up 7. It's just the odd numbers up and over. Yeah.
Anytime it's 1, A is 1.
Right. So when A is 1. So I can graph number 8 so fast. Once I know where the vertex is, so we did that yesterday. Find the vertex, -3, -3. And since this one is up like a cup, I just go up 1 over 1. And there's my first one. And then from that dot, I go up 1, 2, 3 over 1. Buy 1, get 1 free. And I don't even have to plug in those points. So when A is, so even on number 10, right? I have 3, -2. So I got to do the work to find the vertex. But then once I have it, this one's negative, so it's going down. So I go down 1 over 1, buy 1, get 1 free. And then from that point, I go down 3 more over 1, buy 1, get 1 free. So, my goodness, what a time saver. Yeah. So, now, let's talk about when A is not 1. The pattern changes. They all do have a pattern. Your first number will be the same. So, in this case, A is 2, so I go up 2 over 1. Buy 1, get 1 free. But now, to get from the second to the third, now I'm going up 1, 2, 3, 4, 5, 6 over 1. So for 3, am I just doing, let's see what 3 is. So for 3, I go down 3 over, because this one's upside down, right? So I go 3, but then to get to my next dot, 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1.
So we should do this to check our
So you always multiply it by 3.
If A was 2, then you multiply A to
up 1, up 3. Yeah, so just take, so if you know the pattern for when A is 1, up 1, up 3, then if A is 2, you just double them all. If A is 3, you triple them all. But what are you going to do when it's a half? Like it was a half on 6. And this is where I hesitate a little bit because a lot of kids will think, oh, I'm just going to go down 1 over 2. That's not what that means. It literally means you go down half a box over 1, which is not the same as going down 1 over 2, because then your next point will be here, and that's not right. So with fractions, you have to be careful. It does follow the pattern, a half over 1, right, mirrored. And then to get to the next one, and normally it's 1, 3, 5, right? So to get to the next one, instead of going 3, I do 1.5. So here's 1.5 over 1. So yes, there is a huge shortcut for graphing quadratics. I hesitate a little bit with this because if you have your vertex wrong, so let's just say you were doing number 3 and you accidentally, or 5 I guess is what's up on the screen here. So if you messed up on the vertex, you're going to get the entire graph wrong if you just blindly follow the pattern. So I think it's a great way to check yourself, or at least do 1 point. So if I'm doing this one, right, and I got the vertex was at -1, -1, right? So if I'm going to follow the pattern, I should be going up 2 over 1, buy one, get one free, and then what would be next? When A is 1, it's 1, 3, 5. So this one would be 2, 6. So from that second dot, I go 1, 2, 3, 4, 5, 6 over 1. What you should do is pick one of these points now and plug it in and see if you're still right. You get what I'm saying? Because if your vertex is wrong and you're just doing the pattern, every point's wrong now. But when I plug in 0, I should get out a 1. Oh yeah, that does work. If I plug in +1, I should get out a 7. Yep, 2 plus 4 plus 1. Yep, so now that I've quickly checked myself, pretty confident that's my graph. So yes, the pattern can save you a ton of work. Now, the other thing I want to stress to you, let's say, you know, now we're in January, we haven't done this in a while, and it's time for the final, well, I'm sure we'll review, but pretend, I don't know, you're taking the final, you haven't done this in a bit, you can't remember the pattern. You never, ever, ever should leave a graph blank on a multiple choice test. Or any test. It doesn't even have to be multiple choice. You guys can graph any graph in the whole wide world. I could ask you to graph something that was x to the 4th. Do you know right now what that looks like? Y equals x to the 4th if you graph it? Doesn't matter. You can literally just plug in, all right, well, when x is 0, what comes out for y? There's a dot on your graph. When x is 1, what comes out? There's another dot on your graph. You should never, ever, ever leave a graph blank. Even if you forget the patterns or what it's supposed to look like or whatever, it doesn't matter. You just start plugging in points and eventually you're going to get the graph. Another reason why graphs are, when you see a graph on a multiple choice, you should be like, oh, I'm so excited because this is like a gift. Because you can basically plug in 1 or 2 points and be able to tell which graph it is just by that. It's so easy. Just plug in 0, right? See what comes out. If out of your 4 choices, if it doesn't have that as part of its graph, it's not right. We love graphs with multiple choice. Oh, it's like free points. So, any questions about the shortcut? All right.